Right, interesting little bit of avionics here. This is some sort of flight attitude indicator thing that I picked up recently. I think it's got some sort of gyro inside. It's got this message, do not jar, handle like eggs. This I think is a breather similar to they have on hard disks, just to equalise the air pressure inside and outside without letting moisture in. It says it's a Horizon Gyro Mark III, made in England, Sperry gyroscope. Can't see any obvious date on it. It's got this shielded cable and connector on the end. This interesting warranty seal. It's actually like a lead seal with wire, and the wire actually goes through these screws, so you can't take it off without breaking the seal. And there's this interestingly labelled little button here. I can only assume that's to reset the gyro to a certain position. That's interesting. We've got this rotating thing. It feels like there's a lot of weight on the end of this. And we've got this sort of slip ring arrangement. Contacts to make contact with the rotating part. But this feels very smooth, but also very heavy. If I just sort of spin that, it just carries on going for quite a long time. So it's obviously a very precision made piece of kit. There's also some very fine, I can only assume this is grounding or something. On here there's some extremely fine wires from the rotating bit onto this outer. Looks like it's just a solid. Oh, actually no, it's not. I think what this is actually a wire wound resistor. It's sort of wound round in this direction. So this is actually a pot for feedback. So you've got this really super fine spring wires making contact onto this surface, and this surface is actually an extremely fine wire wound pot. It's incredible. So it's not wound all the way around, it's only it's about 270 degrees or so. So that's actually some sort of feedback for the position. And yeah, you can just see as I turn this around, you can see the resistance changing. This screw adjustment here, I think that's almost certainly just balance. It doesn't really go anywhere, so it's just adjusting and position this weight to make sure this thing has no natural position. Wow, amazing bit of electromechanics in here. This again, super smooth, super fine moving internal piece. And again we've got another one of these rotary pots here. Right, this thing is just amazing internally, sort of very nicely balanced. You've got the roll axis here, and then you've got the pitch axis. Yeah, so this axis here is actually driving the front panel needles through this. There's like a little pin in here. This is like a little moving coil meter. That's just an I think this just indicates that the gyro is running, and it's actually giving a reading rather than just being at some random position, so that the pilot knows the system's actually working. And this is actually sprung loaded, so if the power goes off, it just springs back to the off position. And these needles are actually counterbalanced. There's a counterbalance weight down here as well to balance it all. And you can clearly see now how these feedback pots work. You've got these multiple fine spring wires, so that even if one does bounce, you know, you've got enough wires there to guarantee a good contact. And so the wire, it's actually running over a very, very fine wire track. You know, the wire is sort of so fine that it actually feels like quite a smooth surface. It's extremely fine resistance wire there. Now on both axes you've got these sets of coils. Now I suspect this is a Synchro Resolver that transmits the servo position to other systems, maybe an autopilot or something. If you want to find more about Synchro Resolvers, if you look at my Decker navigation control panel teardown, that's got a couple in there and a bit of an explanation. The other thing we've got here is, another interesting thing we've got here on this axis is this, again, similar to the slip rings at the on this axis. This has actually got just a set of point contacts, rotating contacts, because this one doesn't rotate the full 360, so it doesn't need slip rings, so it's easier to actually have something which is where it makes the contact along the centre line, so there's a fairly small amount of friction and rubbing, whereas this axis rotates continuously. And the actual gyro weight is in here. You can just about see there's some little dimples here that have been ground in for balancing. You can see there's some just tiny little, there's a big one there where they've drilled pieces of the weight out to balance it. There's actually quite a lot of these. There's some really tiny ones, so I'd love to know what the actual process is for measuring and calculating these balance weight positions. And you can just see there's some coils on the inside, so I'm guessing this is probably an induction motor, maybe running at 400 Hz, which is a standard avionics power supply. I think these are the connections to it, so it's maybe a 3-phase 400 Hz motor. And there's some tags. Can't quite see what's going on here. There's some sort of component here that's just potted in resin. These black devices at the end here, I'll just open this up a little bit and you can see these are actually Mercury switches. You see the mercury in there, so these will just be to tell when the thing's at a specific level. There seems to be a few contacts within the glass envelope. There's a sort of centre one and one at each end, so those would be some contacts just to tell it which way up it is. Interesting thing I noticed, these three connections appear to be the motor winding, and these actually pass through this little indicator. These red, white and blues actually pass through the windings of this. So what I think is happening here is this is effectively current sensing, so the windings of this actually form another motor of the similar type, so only when all three phases are working and are in the right sequence and current flowing through them will this actually rotate and move to actually indicate that the gyro is actually running. So obviously if this motor's not actually running, the thing isn't a gyroscope anymore and the readings are meaningless. So I think this is a nice sort of fail-safe system, that the only way that this can move across there is if all three phases are actually drawing current through the motor. So any failure of the motor, any failure of the power supply would actually flip that back to off. Right, I'm going to see if I can fire up this gyro. This uses a 400 Hz 3-phase supply. I don't really know the voltage, but I know 28 volts is fairly common in aircraft systems. So to generate that signal, what I'm doing is I'm starting off 400 Hz sine wave from a signal generator. I'm then feeding this into this simple phase shift network, resistor capacitor phase shift network. Because each stage attenuates the signal by a factor of about 10, so the signal's coming in here, I've got like a 100 to 1 and a 10 to 1 attenuator, so I end up with 3 signals which are all at fairly similar amplitudes. I'm then taking those signals and just feeding them into 2 stereo amplifiers. I'm using 1 channel on one, 2 channels on the other, so I've got a 3-channel power amplifier. It's quite important to use a traditional amplifier that's got one side of the speaker grounded, not a bridge output. So what I've done is all the output grounds are connected together but not connected to anything else, and then we've got the three-phase outputs connected from the positive side of the speaker outputs to the three phases of the gyro motor. And you can see on the scope, if I increase the amplitude, we've got our three phases here. And one of these amplifiers is a little bit touchy. It doesn't really like the inductive load very much. If I turn it up too much, it starts going unstable like that. That's not uncommon when you sort of try and drive strange loads with amplifiers. They can do odd things, and that can sometimes result in the smoke coming out. But this one, I think, will just about tolerate running this thing. Alright, let's give this thing some signal and see what happens. You can see that on-off indicator's just flipping out. And you can see the motor, you can see the motor down here is taking its time, so we're probably not giving it as much voltage as it would like. It's gradually starting to spin up. We're getting a fair old speed up now. And now I'd expect when I turn this to actually see some precession. So yes, this is now quite hard to turn, because we're now getting the reaction from the centre gyro piece. It's actually getting sort of really stiff, still speeding up. So now if I'm moving this, the gyro is now trying its best to maintain a position. And now it's stopped, it's now freeing it independently, swinging quite easily again. A couple of noticeable components on there is these two big capacitors. The way they're wired, I think what they're doing is they're using some of the gyro AC supply to as the excitation supply for these coils, which I believe are Synchro Resolvers. So they're just tapping off the same supply, and they're using that as a capacitive dropper just to limit the current. One other thought I had is, I'd say these could be Synchro Resolvers. I'm wondering if they also might have something to do with this fast direction button. Maybe they're perhaps being used as motors to move it to a specific position, maybe even in conjunction with those Mercury switches. I don't really know, so maybe someone that knows a bit more about fast directions might be able to let us all know in the comments. Had a quick hunt around online and I found this old advert from 1951 for what I think is either this or a very similar device. This is described as the Spare Electric Gyro Horizon Type HLL5 Mark III. One thing it does say in here is that the supply is 115 volts at 3-phase, 400 Hertz. So maybe I wasn't running it anywhere nearly as fast as it should have been running. That might also account for some of the drift I was seeing. I'm probably going to need a much chunkier amplifier to get that. The way I'd probably attempt to do that is to take an audio amplifier and then stick it through a mains transformer wide backwards to get a higher voltage supply. But this amplifier is just too unstable to do that. If I can find another amplifier, I might have a go at see if I can crank it up to full speed at some point. So there you have it, a really nice bit of electromechanics from about the 1950s. I'm not going to take this any further apart. I don't think it's really that much more interesting. I think it would just be a shame to for something that's just this nicely made to take it to pieces. Plus, let's say at some point I'm going to see if I can rig up a proper supply to run the gyro at full speed and see what it does then. But I think I'm going to, there's probably not much particularly interesting. I mean, I don't know, there might be some interesting details to this bearing. This is obviously a very precision bearing on the motor that's got probably all these adjustments to precisely adjust the tension and everything to get it to run as smoothly, because the smoothness of the gyro is probably one of the most important things in its performance. But I'm just going to leave this, I think, as a nice piece of beautiful electromechanics.